Okay, so today we are going to look at arithmetic sequence, and that's going to be 1-4. And remember, this is a review, so remember to look back at it in your book when it comes time. So an arithmetic sequence is one where you add to find the next number. That's why it's arithmetic. That's why it's called arithmetic. So in this first example, we're looking at an arithmetic sequence, which is a sequence with a consistent difference between its consecutive terms. Common difference, and these things are going to be our D. That's what we're looking for, D for difference, and that's what they use. So when we're looking at this one right here, what happens is you're looking at what's the difference between 3 and 5. I'm sorry, 3 and 8, which is 5, because I had 5 on my brain. Why is it not letting me write? I don't know. Hold on, there we go. So between each of these terms, long story short, it's going to be 5. And between this and this, if I wanted to do the next term, I could just add 5. And I would say that my answer would be 28. So that's simple. But the explanation for that is this. Whenever you go to a 50th term or a 30th term, you don't want to have to go all the way through it. So basically what they're doing here, if it would do what it's supposed to do, they're saying that your n is equal to 1, which would be like the beginning spot, where f of 1 is 3 and n is greater than 1. F of 2 is equal to, so that's a second term, is equal to f of 1 plus 5, and so on and so forth. And that's how they finished out this sequence right here. So in this recursive form, what they're doing is they're looking at this and saying, okay, so if I give you 4, 10, 10, 13, 16, if I'm starting at 4, and n is equal to 1, so it's one term, then n minus 1 plus what is going to be greater than 1. So they're looking for the blank. So basically you're looking back and saying, oh, between these two there's 3. Oh, between these two it's 3. And it has to be the same difference all the way through. So that would be 3. So you would just fill that in. And in example B, they're just kind of going through that and showing you how to find the next term and the next term. This is a recursive form. So in this example, they're giving me, and this is the try it, and this is on page 32. They're giving me 25, 20, 15, 10. So what's happening? Basically, it's subtracting 5 each time. So it's going down 5. So you're just going to have to look and say, okay, so what's happening? So this one, if I was writing it out, and they might ask you to do that, you're going to say 25, because that's your first term, that's your a of n, where n is equal to 1. And then you're going to have a of n minus 1 minus 5, which is the term, where n is greater than 1. So that's how they're going to want you to write it out. Then the next one is example B. I think it's on the next cart. Nope, this is example 2. I'll go back. That was example B. So example B in this situation is down. Let me go down here. So maybe I don't have it. Is going to be not arithmetic. Where is that one? Okay. So example B. They're giving me 2, 4, 7, 12, 13. So when I'm looking, I'm saying, okay, the difference of 2, difference of 3, difference of 5, difference of 1. So this one is a no or a not arithmetic because it doesn't have the same consecutive difference all the way through. So that was just on the try it, giving you a couple examples. Okay, so then we're looking at the second one, which is going to be example number 2 in your book on page 33. And this is going to be the recursive definition. Basically, this is how you could find the 50th term. And I love this one because then you don't have to go each term, you don't have to guess, you just plug everything in. So they're giving me a sequence, 3, 6, 9, 12. So I know what's happening. So each time I am adding 3. That's what I'm doing. Basically, that is going to equal my distance. So A1 is the first term. So A of 50 is going to be what we're looking for. So we're going to say A, that doesn't look like an A. A of 50, because it's a 50th term we're looking for, is equal to 3 plus 50 minus 1 times my difference, which is 3. So then I would just solve that out. So basically I have 3 plus 49 times 3. 49 times 3 is going to be 147, plus the 3 should be 150. So the 50th term, A of 50, that doesn't even look like 50, but A of 50 is going to equal to 150. And that's how you would find, you could have found the 25th term if you wanted to, by just plugging it in and following the steps. That's what I like about the recursive form. You can find whichever one you want by plugging things in and solving it out. Okay. Example number 3, they're talking about an auditorium, and it says a high school auditorium has 18 seats in the first row and 26 seats in the 5th row. The number of seats in each row forms an arithmetic sequence. What is the explicit definition for the sequence? So basically what you're looking for is they want you to find D. They're giving you the end. You have to find the beginning. So you have to go through and do that. So you're going to have A of 1 is going to be 18. A of n is going to be 26. Plus the n, which I don't know, but actually I do because it's 5, right? They told me 5. So let me take off the n. Get my pen back, and that's going to be 5 minus 1 times my difference. What I don't know is my D. That's what I'm looking for. So I would have 26 is equal to 18 plus 4 D, because it's 4 times D, and then so that's going to be minus 18 minus 18. So I have 8 left. 8 is equal to 4D divided by 4. So that 2 is equal to D. So your difference in each row is going to be 2 seats. So it's 2 seats wider, or the previous row is 2 seats shorter. So however you want to look at that. But that's how you could use it in a word problem. All right. So before I go to the next example, example number 4, I'm going to tell you that your keyword for this video is shark. Okay, so in example number 4 in your book, they kind of explain to you the arithmetic series of using the summation principle. So that is what they do there. So basically they go through and they have you do this problem and they show you why it works. So now let's do an example using it. You can look it over. So you have example B. What is the sum of the following arithmetic sequence? 2, 6, 10, 14, 18, 22. Okay, so we have this arithmetic sequence. We know the formula. They explained to us why we had it and why we used it. So now we plug it in. So I have the first term, which is A of 1, which is going to be 2. And I have my last term, which is 22. And then my difference, basically, between the first one and the last one. So my A of n is going to be 6. My number of terms actually is going to be 6. So then we're looking at that, and now I just solved that out. So basically I'm going to have 44 times 6 divided by 2, and it is equal to 72. The sum of my numbers is 72. Why did I say 44? It was going to be 24 times 6. I don't know why I had 44 in my brain. Sorry, guys. This is going to be 24 times 6, which would have been 144. Maybe that's why. 144 divided by 2, which is 72, for the sum of that group. example number 5, is going to be the summation. And they kind of go through the whole thing and solving each and every one out in this problem to find out that you have 12 terms. So that's on page, example A is going to be the explanation for where they're getting this. So B says, how can you write a series 2 plus 9 plus 16 plus da 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 all the way to plus 79 in sigma notation? What is the sum? So in sigma notation, what you're going to have to do is, notice they're going to use your arithmetic sequence, which is going to be the same thing that they did up above, but you're going to do it without having to go through all those steps. So what happens is they give us this. So I have my A of n. Let me go up a little bit. A of n. Oh, I already wrote it down to the side. Okay. So A of n is going to be 79. Pens. Pen, pen, pen. $79. A of 1 is our first term, which is going to be 2. Plus my difference between each term is going to be 7. And then they're looking for, which term are they looking for? The sigma notation for the sum of these numbers. And it is the difference they're telling us is 7 and A of 2. So I guess basically I'm looking for n. So and I have n minus 1. So I solved this out. Sorry. So I'd be subtracting 2, subtracting 2. So I have 77 is equal to 7 n minus 1. So I would divide through by 7, make it 11, which is equal to n minus 1, plus 1, plus 1. So 12 is equal to n. So it says the number of numbers, there are 12 terms in the series. So that tells us how many terms there are. And then that's continued out to plugging it in. So when you're looking at that on the next, I can go down instead of do another page. So when you're looking at that, that means that's going to help you with where you're putting your numbers in your sigma. In your sigma, or your summation thing, basically, that means that you're going to have 12 numbers in your series. And you have your I is equal to 1 because I equals 1. And then I'm going to have my 7I, and then the difference is going to be minus 5. So there's your formula for when you plug it in to find your numbers. It said, write an explicit formula for these series. Write in sigma notations. Well, they gave us the whole formula there. So they told us what it was. We found the number of terms over there, and then they had given us this. They had given us A of n, because I didn't write this down in case you need to see it and you don't have your book. 2 plus 7 parenthesis n minus 1. I guess it's, oh. Do you see the 5? All I did was take that. I did the 2 plus 7n minus 7, and that gave me 7n minus 5. And in place of the n, they plugged in I, so 7i minus 5. If you're wondering where that came from, it's this line right here, basically, but just distributed out. Okay. So the only other thing that you might have a question on your test might be your finite system, which a finite system is like this. A pyramid of cans has one can, has row 1 with one, I can't even talk. Top row has 1 can, the second row has 2 cans, third row has 3 cans. If there are 10 rows of cans, how many total cans are used to make the pyramid? So what you're saying is you're going to know that A of 1 is 1, and your formula is going to be A of 10 because you're looking for the 10th row, and your A of 1 plus your D parenthesis n minus 1. So now you're solving this out. So I know I'm looking for the 10th term, so it's going to be 1 plus D parenthesis, or your D was, and then your n is 10 minus 1. So then you have Your difference on each row is going to be 1, so it's 1, 1, I don't know what happened. There we go. It's going to be 1 plus 1 parenthesis 10 minus 1, so it's 1 plus 9, so that's going to be a total of 10. So equals a total of 10 cans. So that's what we're looking for there. So now we take that and we use that step 2 to find out how many total cans. So that gives us our A of 1 and our A of 10. So that we know that we're plugging it into our formula that says S of n is equal to 10 parenthesis 1 plus 10 all divided by 2. So that's going to be 11 times 10 divided by 2. The simplest one is 11. It's going to be 110 divided by 2, which is going to be 55. What makes it look like an 8? This is not even what I wrote. So it's 55 cans total. So that's how you could use the finite. You have to find your, basically what this value is and plug it in, so then you can go through and find your total answer using the finite arithmetic series. So look back at this. If there's questions, let me know.